Hello, my name is Muhammad Idris Firdaus, and today we are from Group 5. We'll be presenting about our foundation engineering project. For introduction, geotechnical and foundation engineering expertise should be used in foundation analysis. The load that will be transmitted by the superstructure to foundation system, the requirements of the local building code, the behavior and stress-related deformability of soils that will support the foundation system, and the geological conditions of the soil under consideration are all required knowledge for the design of structure foundation. The analysis and design techniques are critical for producing a structural building that is stable and long-lasting. The soil research study can be used to support the feasibility of deep or shallow foundation design. The objective of the project is to study and analyze the soil profile based on the obtained bore log. Second is to design a suitable foundation for column withstanding the proposed load. And the third is to determine whether any soil improvement initiative in foundation construction are required. Next is the project description. This project purpose is to propose a design of foundation based off of the report of soil investigation carried out for construction project of a mosque located on lot PT 11747 Hulu Langat, Mukim Beranang, Selangor. The soil investigation works were conducted for Masjid Bandar Tasik Kesuma, and there is 4 deep borehole was conducted at the proposed site. As you can see here, these are the location of the project and the location of the deep borehole. And finally, this is our proposed foundation key plan for this project.
Hello, my name is Nazar Amir bin Nazri. My metric number DF10122. The next part is soil profile analysis. To obtain the soil profile, our group analyzed the bore result at borehole 2 and borehole 4 because of the building proposed location is located around the borehole 2 and 4. Based on the bore result, the soil strata and its strength is obtained as shown in diagram beside. The diagram of the soil profile obtained after interpolating the soil layer in borehole 2 and borehole 4. As we can see in this diagram, first of all, the water level is at the 6 meter, and from the topsoil until 5.5 meter, it is a steep sill. The next layer is sand, which is medium dense sand and loose dense sand, and at 11.5 meter is very steep sill and steep sill. For the 21 meter, it is medium dense sand, and the last layer of the soil is very dense sand, and there's a presence of a gravel. That's all from me for the soil profile analysis. Thank you.
Hi, my name is Muhammad Aziz Wahid bin Azhar, and we metric number DF190113, and today I'm going to present about the foundation design and soil bearing capacity. So after the bore log analysis, we have to find unit weight for each layer of the soil. So from the soil profile, we found out that our soil was silt stiff. So we assume our unit weight above the water table is 16 and below water table is 19. So we can see from the table because the site investigation report do not provide the laboratory test for unit weight of the soil, so we assume it. Bearing capacity in general, equation 5.1 will be used to calculate the allowed bearing capacity for square and rectangle foundation, which is we are using Terzaghi equation as below. We can see the equation in the equation 1. After that, we calculate the allowable bearing capacity using the equation 2, which is QU over safety of factor. And the value NC, NQ, and NY can be obtained from the table provided, as we can see in the slide on the left, which provided from Terzaghi. We can find the unknown value by referring to our friction angle. After obtaining the allowable bearing capacity, we key in a new bearing capacity into esteem, which is our bearing capacity is 4 to 5 kilonewton per meter square. We key in the value into esteem 10 software, which result in new foundation design proposed, which is 1.45 meter times 1.5 meter for the breadth and width. After obtaining the new proposed design, the size is 1.45 times 1.45 meter. We need to check the requirement, which is the new bearing allowable bearing capacity should be bigger or higher than the axial load at the column C22. Okay, so we got the result that after using the newly proposed design, we got the Q is higher than P, so it's okay and it's passing the requirement for the shallow foundation. That's all from me. Thank you very much.
My name is Muhammad Izzat Najmi bin Muhammad Azam. For my part, I will present to you the discussions. PET Foundation 21 was chosen for analysis based on the proposed building design because it bears the most critical load of 866.8 kilonewtons. This is due to the fact that the PET foundation bears heavy loads from multiple slabs and a column height of 7 meters. Next, the allowable soil bearing capacity in this project is 425 kilonewton meter square. The parameter is entered into STEAM software for analysis and generation of the load from column and PET foundation dimensions. The load from column 22 is 866.8 kilonewton and the dimensions of the PET foundations 21 are 1.45 times 1.45 according to STEAM software. The calculated allowable soil bearing capacity is 893.56 kilonewtons, which exceeds the load carried by the PET foundation, which is 866.8 kilonewtons. As a result, the PET foundation 21 is successful. Finally, based on the analysis, the calculated settlement value is 12.23 mm, which is less than 25 mm, indicating a success. As a result, the type of foundation used in this project is a PET foundation. That's all from me. Thank you.
Hi, my name is Muhammad Shafizul bin Musa, matric number DF190125, and I will talk to you about soil improvement and conclusion for our project. Soil improvement is the modification of a soil to improve its engineering performance such as strength, decrease compressibility, reduce permeability, or better groundwater condition. A variety of ground modification techniques can be employed to stabilize or enhance the condition of an area of ground prior to building activity. There are two methods of soil improvement, which are soil replacement and pre-compressing or pre-loading. Soil replacement is one of the most basic and oldest means of improving bearing soil conditions. Almost any soil can be used as a replacement layer for an inferior soil such as clay or sandy soil by replacing it with more capable materials such as sand or crushed stones. For the pre-compression and pre-loading method to building foundations can be successful on clayey soil. Preloading may not be a viable option for the building on clayey soils. Sand and vertical drains can be employed to speed up the process of consolidating clayey soil into pit bogey areas rather than clog it with water-logged slurry. For the conclusion, the foundations are the most critical aspect of any construction project. If not done correctly, they may endanger the structure's strength and resistance once completed. Construction will not be trustworthy or long-lasting unless it has a strong foundation. A deep foundation is required for a tall building, such as skyscraper or one built on unstable land. The weight of the structure is transferred to a deeper depth below the ground surface by the deep foundation. This suggests that the PET foundation can withstand higher weight and provide a solid foundation. Knowledge in foundation engineering such as analyzing bearing capacity and elastic settlement, as well as data block analysis will be valuable to us as civil engineering in the future. Finally, the foundation engineering skills obtained were put to excellent use in this project. It is also possible to remarkable that our project's objectives were accomplished with success. So that's all from us. Thank you.